Welcome back. This is part 3 of a video trilogy on what is known as scientific consensus. How prevalent is corruption in scientific consensus? And can it be so prominent as to distort the scientific consensus? These are questions I'm going to attempt to answer. Meta-research, or research about research, is something that's been studied quite a bit in the past couple of decades. Scientific misconduct, specifically, has received special attention, and there is quite a bit of empirical data on this, with relatively consistent results. Let me share some of it with you. A 2005 study in Nature found that for the main forms of scientific misconduct, fabrication, falsification, plagiarism, or data modification, roughly 2% of scientists admitted anonymously to having committed some form of it. There were higher amounts reported for other types of misconduct, though these were the less severe types. In other studies, with smaller and less widely representative samples, the admitted rates of the main forms of misconduct ranged from 1 to 7%. Perhaps most all-encompassing, a meta-analysis in 2009 on scientific misconduct found that roughly 2% of scientists admitted to having fabricated, falsified, or modified data or results at least once in their careers, but noted that this was likely a conservative estimate. Some critics have suggested that rates of misconduct are underreported. However, many studies that asked scientists about the behavior of their colleagues did not control for duplicate reporting. So a 2008 study attempted to do this and found that over a 3-year period, a rate of the equivalent of roughly 3 cases per 100 people per year was found, so around 3%. From March 2008 to March 2014, of the 113,000 records in the FDA's Inspections Classifications database search, 3.7% of them were classified as, quote, official action indicated, relating to a severe form of clinical trial violation, though there are indications that the FDA fails to disclose many of these cases to the public and to journals. And finally, a recent study tried to answer how much money scientific fraud wastes. The findings, published in the eLife Sciences journal, were as follows. Quote, we found that papers retracted due to misconduct accounted for approximately $58 million in direct funding by the NIH between 1992 and 2012, less than 1% of the NIH budget over this period. So it seems, from all the literature on this topic, that scientific misconduct and corruption is certainly a real problem, but a lot less than what many people claim. It seems that a small significant percentage of research is tainted with severe forms of misconduct, and that a larger but still small minority of research is tainted with less severe forms. Another problem that can infect the scientific literature on any given topic is what is known as publication bias, which is when only a select portion of data is published for a given topic. For example, when only positive clinical trial data for a new drug being tested is published, while the negative data is withheld. This is a large problem, and I'll discuss it more in depth in a future video. Suffice it to say for now that consensus typically isn't established in immature fields where publication bias is likely to be a problem, though there have been known to be faulty approvals of drugs on occasion whose backing research was tainted with publication bias. However, using publication bias as a reason to doubt all scientific consensus positions, absent a rigorous analysis of the evidence on whether the problem exists in a field, is unjustified, and often is just done to promote doubt over all science, which is not helpful to understand the scientific literature as a whole. This is even more reason why we need to be sensitive to what the bulk of the evidence, and thus consensus, points towards. The inherent process of science is a bias mitigating one, and thus one that protects against corruption. Thus, the wider the consensus, or stronger the convergence of evidence of a particular theory, the less likely it is to be tainted by any sort of bias. I won't claim that corruption of an entire scientific consensus is outright impossible, but I think it's safe to conclude that it's hugely implausible, especially as the body of evidence grows larger and if similar results are ascertained from many different funding and research sources. Perhaps this was demonstrated best when Big Tobacco ultimately failed to distort the scientific consensus that smoking is a major risk factor for lung cancer, or when Big Oil failed to distort the scientific consensus that anthropogenic or man-made climate change is occurring. These are two of the biggest industries, and though they succeeded, at least temporarily, in sowing doubt amongst the public about these issues, the scientific evidence prevailed. This was all documented in the critically acclaimed book Merchants of Doubt by Naomi Oreskes and Eric Conway, which shows how powerful campaigns were orchestrated by the right-wing political and corporate establishment to spread doubt and confusion about these scientific findings, even after there was large consensus for them. So let's stay away from outlandish claims like the scientific consensus is corrupt, which is an extraordinary claim that requires extraordinary evidence. It's extraordinary because it asserts that a vast body of evidence, and thus the scientists performing it, have all somehow been corrupted by something. How is this exactly supposed to work? By all means, let's discuss to what extent corruption or scientific misconduct affects the practice of science. But let's apportion our belief about this to the evidence available, and try not to let any of our social or ideological outlooks cause us to ignore or deny this evidence. Hostility towards scientific consensus positions, especially the outright concept of scientific consensus itself, is usually a red flag for identifying someone engaging in fallacious reasoning, or projecting some sort of ideological bias into their assessment, often invoking some form of science denialism or conspiracy theories. These are two topics on which I'll do my next series.